This is another question under the topic vectors. Vectors in 2 dimensions. The position vector of the points A and B are 3i plus 2j and 6i plus nj respectively. Find the value of n when A and B are parallel. Find the value of n when A and B are perpendicular. So the question once more is going to test our knowledge of parallel and perpendicular vectors. We're going to use the knowledge of parallel and perpendicular vectors to be able to find the value of n. How is that done? Let's look at the solution. The position vector of the point A is 3i plus 2j. The position vector of the point B is 6i plus nj. Now, the first part, we are told that A and B are parallel. Now, if that is true, it simply means that one of the vectors is actually a scalar multiple of the other. For example, A should be a scalar multiple of B. Okay, K is simply a real constant. If this is true, then the vector A is parallel to the vector B. So all we need to do is to solve for K in this equation. If we can come up with any real number K such that this equation is true, then the vector A and B are parallel. Now let's put the vectors A and B. So A is 3i plus 2j is equal to K into 6i plus nj. Okay, now let's open this parenthesis. So we have 3i plus 2j is equal to 6ki when we take this k and multiply to 6 plus kng when we take this k and multiply to n. Now we have this vector equals this vector. What is the condition for the equality of two vectors? Two vectors are equal only when corresponding components are equal. The I component is equal to the I component, the j component equal to the j component. That's the condition for any two vectors to be equal. And so if we do that, we will now have for the I component on the left hand side, the vector on the left hand side, the I component is 3. It should be equal to the I component of the vector on the right hand side, 6k. Take note, we don't include the I again. We're just taking the coefficients or the components. The component of I here is 3, the component of I here is 6k. So from here, we can get the value of k if we divide both sides by 6. So that we see that actually the value of k is a half. Okay? So we've been able to find a real number, k, that should be able to render this expression true and valid. Now, if comparing now this was the I component. Let's put and circle it there. Equating now the j component. The j component on the left hand side is 2. We equate it to the j component on the right hand side. So we're saying 2 is equal to kn. We already know the value of k. The value of k is a half. So let's put it there. So half 2 is equal to a half times n. It's the same as 2 equals n all over 2. To be able to get the value of n, we simply multiply both sides by 2. Multiply here by 2, multiply here by 2. You can see that these two cancel so that we have n. N is now alone. So we're able to read now the value of n as 4. 2 times 2 is 4. So we'll now say n is 4. Okay? So we have been able to find the value of n for which the vectors a and b are parallel. That can only happen when k is also a half. That's scalar. That will render the two vectors parallel. It can only be a half, as we have just seen. That does it for section A of our question. Now let's look at section B. Section B, it says that A and B are perpendicular. This time around, they are perpendicular. Now, if the vector A and B are perpendicular, it therefore means that their dot product must be 0. That is a property of perpendicular vectors. We should always remember that. If A and B are perpendicular, it means A dot B must be 0 for two vectors to be perpendicular. All right, so now let's put in the position vectors of A and B. So it simply means 3i plus 2j dot 6i plus nj. That dot product must give us 0. So this is the equation that we have to solve. You see, the only unknown is n. So we're now going to solve this for n. All right, remember with dot product, I go with I and j go with j. The reason I gave in the last video, again, we should remember I dot I is 1, just like j dot j is 1. But when we have the two different components coming together, I dot j, the result will always be 0. The result will always be 0. So there's no need taking I dot j here or j dot I. You see, there's no arrow for this and there's no arrow for that because we know the result will be 0. So we just go ahead and take only I dot I, j dot j, I dot I, j dot j. All right, this becomes this becomes 3i dot 6i plus 2j dot nj. We expect that result to be 0. Remember, I dot I is 1. So we'll just left here with 3 times 6, which is 18. J dot j is 1. So we'll just be left with 2n is equal to 0. So this is the equation we have to solve for n. If we take this plus 2n to the right hand side, it becomes negative 2n. Remember, we're solving for n, so we have to divide both sides by negative 2 in order to remove the negative 2. Negative cancels negative, 2 cancels 2. So we can now see n is alone. And so here we have 2 here, 1, 2 then 9. The negative goes up, so we have negative 9. So our conclusion, the value of n here will be negative 9. So that will be the value of n when the vectors a and b are perpendicular.